आता दिवस सकाळपासून
पहले मैंने मुझे ध्यान ही नहीं रहा, थोड़ा मैंने वो ही नहीं करा, कैमरा ऑन नहीं करा। सॉरी, मैंने ध्यान नहीं किया था, थोड़ा मैंने वो मेरे को जानते भी कौन सा है, कैमरा ऑन नहीं करा। सॉरी, मैंने जानते भी कौन सा है।
A very good afternoon to one and all present here. Welcome all to the its honorable webinar. It's an honor itself to honor this beautiful audience, participants who has joined over here. I, Mr. Prachaldok, Assistant Professor, Department of Chemistry, welcome you all on behalf of whole Rashtrapita Mahatma Gandhi Arts and Science College Nagbid family on this one-day webinar regarding the topic application of carbon material. Thank you all for giving us your prized time. Before the launch, first of all, I warm welcome the dignitaries. Let me first acknowledge the presence of some of our immense guests, Dr. A.N. Korpenwar sir, Principal, Rashtrapita Mahatma Gandhi Arts and Science College, Nagbid, Dr. Harshal P. Mungse sir, Department of Chemistry, Adarsh Science College, Dhamangao, Sant Gadge Baba Amravati University, PhD from Council of Scientific and Industrial Research, Indian Institute of Petroleum, Dehradun, India, and postdoc JCPS Fellow from Japan. Our next immense guest, Dr. Devkinandan, Department of Chemistry, Government Science College, Tanakpur, Kumayun University, Uttarakhand, and PhD from Council of Scientific and Industrial Research, Indian Institute of Petroleum, Dehradun, India, and postdoc from Czech Republic. We have our traditional auspicious lamp lighting ceremony as a tribute to Mother Saraswati, the goddess knowledge. Mother, we pray for your blessing with your humanity, gives us wisdom to make this world a better place. May all the being live in harmony with the nature, other from the life. May the truth prevail. May the darkness of ignorance be swept away by the drawn the self realization. 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 Away by the drawn the self realization.
YouTube चालू नाही आहे इथं कुठं तिथं चालू आहे का
Now, beloved participants, our Honorable Principal Sir, Dr. A.N. Korpenwar Sir, Rashtrapita Mahatma Gandhi Science College Nagpid, are going to addressing this beautiful webinar through their valuable introductory speech. Webinar through their valuable introductory speech. Webinar through their valuable introductory speech. Webinar through their valuable introductory speech.
Arts and Science College Nagpur.
Webinar through their valuable introductory speech.
On Arts and Science College Nagpur.
Webinar through their valuable introductory speech.
On Arts and Science College Nagpur.
Webinar through their valuable introductory speech.
Our Department of Chemistry, Rashtrapita Mahatma Gandhi Arts and Science College Nagpur has organized one-day online national webinar on applications of carbon materials. Our Department of Chemistry, Rashtrapita Mahatma Gandhi Arts and Science College Nagpur has organized for this seminar one-day online national webinar on applications of carbon materials. Our Department of Chemistry, Rashtrapita Mahatma Gandhi Arts and Science College Nagpur has organized for this seminar one-day online national webinar on applications of carbon materials. Our Department of Chemistry, Rashtrapita Mahatma Gandhi Arts and Science College Nagpur has organized for this seminar one-day online national webinar on applications of carbon materials. Department of Chemistry, Rashtrapita Mahatma Gandhi Arts and Science College Nagpur has organized one-day online national webinar on applications of carbon materials. Department of Chemistry, Rashtrapita Mahatma Gandhi Arts and Science College Nagpur has organized for this seminar one-day online national webinar on applications of carbon materials. Rashtrapita Mahatma Gandhi Arts and Science College Nagpur has organized a seminar, one-day online national webinar on applications of carbon materials.
atoms arranged in two-dimensional honeycomb lattice. It is the building block of other graphitic materials, or we can say This graphene is a mother of other graphitic material. Why I am saying this graphene is known as the mother of other graphitic material? You can see in this slide, if we can roll this graphene sheet, then there is a formation of one dimensional nanotube. If we wrap this graphene sheet, then formation of buckyball, or we can say the fullerene, and this graphene is the single sheet. So if we stack this graphene sheet for each other, then formation of three-dimensional graphite.
इंग्लिश में पढ़ा रहा मेरे को
The
समझ
building block material for other graphitic material. And what was the problem? For Konstantin Noaslo and Androzim and their colleagues from Manchester reported the existence of graphene, that is two-dimensional sheets of carbon. But before that, some scientists said this discovery took the world by surprise, because the almost 70 years earlier, physicists had argued that the materials like graphene will be too thermodynamically unstable to exist. So it cannot possible to exist these two-dimensional materials. The next step is how and why this idea comes. It comes from, we can compare, for example, the copper nanoparticles and copper, or gold nanoparticles. Everybody knows why we are synthesizing the nanoparticles, why we are synthesizing gold nanoparticles or what copper nanoparticles. We know that the nanoparticles is having significant or remarkable properties as compared to the bulk material. So if we decrease the size of that material, the properties are changing. So they thought, now we know that this graphite contains the number of layers of graphenes. So if we separate the single sheet, what then we can compare the properties of graphite and properties of graphene, like the nanoparticles. But problem was how to separate the single sheet from graphite that contains many numbers of layers of graphene. But how to separate? This was the big problem. So many scientists tried by using oxidation method, by using different mechanically separation methods, but they failed. But one of the simple idea, the very simple idea, can work to separate this single sheet from graphite. And the next slide, I have shown the how simple idea in the research, the simple or idea is the very important. The lab facility sometimes no need, but the strong point is our idea, our thinking is the most important in the research field. Now from this example, I think those who want to do PhD, those who want to enter in the research field, this is the motivational example for the students. So you can see that graphite structure, there are number of layers of graphene layers, and how we can separate this single sheet. You can see the graphene two-dimensional, that is the single sheet graphite that contains the number of graphene layers. Now problem is how to separate. So what the Androzim and Konstantin Noaslo, they just took the scotch tape. They just put that scotch tape on the graphite material. What happened? The some of the layers will peel out with the scotch tape. Then, for example, if there are 4 layers of graphene, then in the next step they again put the adhesive tape or scotch tape, then again peel out some layers. For example, out of 4, now this adhesive tape is having 2 layers. So they repeated this procedure, and at final that adhesive tapes or substrate is having only single sheet, and then measured the properties of that material. What they found, this material is having extraordinary properties as compared to other graphitic material. So for this experiment, I have shown in another way in this slide. First of all, graphite attached to the surface or substrate, then place adhesive tape on the graphite and peel out, taking some layers away. I have already explained in previous slide. Then we can repeat this procedure, the peeling process. Finally, one that is single layer of graphene remains. So by this way, this androgen and constitutive nolosoro, they prepared this graphene sheet. That is, we can say that is the micromechanical cleavage method to prepare the single sheet or to separate the graphene sheet from the graphite substrate. And you can see how the lightest material is this. You can see this material can survive on this cherry flower without bending this flower, and from this we can observe how the lightest material is this. And these are the two scientists, that is Androgen and Konstantin Novoselov. They got the Nobel Prize in 2010 for these groundbreaking experiments regarding this two-dimensional material, that is graphene. Why this material got Nobel Prize? Because this actually it is very difficult initially how to prepare this single sheet, and when other researchers studied the properties and applications, they are having remarkable properties as compared to other materials. So in the next slide, I am going to discuss about the properties of this.
देख वो भी
Hello, please, Dr. Muksha sir, your sound is not there. Please on your sound first. Hello. Dr. Munkshe sir, please on your sound. I think unknowingly, yeah. Yeah, sir, please. Yeah. Thank you. Please go ahead, sir. Go ahead.
Just a minute, just a minute. I have to share screen.
Yeah, sure.
Yeah. Now voice is clear, I think.
Yeah, sir, please, sir. Go ahead, sir.
Okay.
Good. Good.
So now I am going to discuss about the applications of graphene. This is applicable in the catalysis because of the high surface area. We can use this graphene material as a support in the catalysis field. It is applicable in fuel cells. It is applicable in lithium ion batteries. We know in the batteries previously we used the graphite powder. Now we can replace by using this graphene material in the lithium ion batteries. Next application is the gas adsorption and storage. We can use this graphene in the solar cells. We can use this graphene material as in the supercapacitors and tribology. This tribology, I think the new term for the UG or PG students. So I will discuss about the tribology in detail, and that is my research topic during my PhD. You can see the applications of this graphene in various fields, in transistor, in solar cell, in catalyst. You can see in the catalyst this graphene material used as a support in gas detection and adsorption, touchscreen devices cell. Nowadays graphene they are using, and finally this tribology or lubricants, how we can use this graphene material in tribology and why we are using this material in tribology or in lubricants. And this was my PhD topic. So I will discuss about the tribology, but before I want to tell, as we are not serious about the global warming or environmental issues, lot of discussion, lot of international meeting on how to reduce pollution and emission of CO2 gas, but human being fail to do this. Now who is responsible for increasing the pollution in environment? I think only human being. If we are not doing at right direction, what will happen? Then nature will take the charge. I am saying nature will take the charge. Why I said nature will take the charge? You just see the example. Nowadays the pollution level decreased after the lockdown because of COVID-19. So if we are not doing in right direction, then nature will take charge. So if we are not doing this properly, after some years, some periods, nature will play his role in future also. So now about tribology, why I said this statement, because in the tribology, and what is the use of tribology? It is useful in the conservation of energy and increasing the lifetime of machines, and importantly it can decrease the emission of CO2 gas in the environment. Now this is the new term for some people, so I am going to discuss about the tribology and its applications. So what is tribology? It is the science and technology which deals with the study of interacting surfaces in relative motion. You can see these bodies are in relative motion. So because of this motion, there occur friction, there occur wear. Now this is again the new term, wear. What is mean by wear? Wear is just the removal of or loss of some material. Because of this interacting motion, some material will get lost. So that loss of material is known as wear. Now how we can reduce this friction and wear? We can reduce by using lubricants. Now what is the lubrication or lubricants? In the lubricants formulated by using the lube based oil and the additives. That additives, there are different types of additives. and depend on the that specific applications. You can see, so maybe 80 or 90% lube base oil, and remaining percentage is of these additives, specific additives. So this is about the tribology. Here I have given example, the effect of lubricant. You can see, first case is the without lubricant, and second is the in presence of lubricant. If we use the lubricant, what will happen? Just see, just see. What is happening? In the presence of lubricant, that body is moving fast. Why this body is moving fast? Because that lubricant will reduce the friction, and that's why this body moves faster as compared to the first case, that is without lubricant. So this is just example to understand the effect of lubricant. Now, why there is a need of lubricant? We know that nowadays too many transportation activities increases. So it is recorded that because of this, transport sector consume 20% of the global energy and accounts for the 18% of the total greenhouse gas emission. The road transportation is identified as one of the major source of rising CO2 in the environment. The 33% of fuel energy is consumed by the passenger cars to overcome the friction in engines, transmission, tires and brakes. The implementation of advanced tribological solutions and lubricants technology can conserve as much as 17.5% of energy being utilized in the road transportation, which equal to annual saving of billions liter fuel and reduction in CO2 emission. So that's why this tribological applications is very, very important. This is, we can give the direct effect on the environment if we use the efficient lubricants. So because of poor lubricants, failure of engine tools, you can see these images. Because of poor lubricants, increase in the greenhouse gas, too much fuel consumptions, high energy consumptions, discharge of partially oxidized fuel. So we can reduce all these if we if we apply the excellent lubricants. So in this regards, I have worked in the PhD, and how we can measure the friction and wear, I have shown in this the instruments. The first one is the 4-wall tribotester. By using this, we can measure the friction, and also from the steel balls some material will get lost, and we can measure from that the wear or wear scar. And this is the another image is shown, that is the 4-wall geometry. In the first wall, that upper wall will rotate, and the remaining three balls that are stationary. So we can vary the load, temperature, and depending on the conditions, that what is the load, what is the temperature. So we can measure the friction as well as wear by using this tribo instrument. This is another instrument. These instrument, before I have shown these instrument, we can use in the liquid lubrication or in the liquid lubricants case. However, this instrument we can use if we deposit the graphene sheet on the silicon vapor. So in that case, we can use this nanotribometer instrument to measure the friction and wear. So these are the instrument which I have used. Now we have seen the proper applications of graphene in various fields. Now what is the role of that graphene material in tribology? We know that friction and wear are two major events for energy and material loss. Till date, these zinc dialkyl dithiophosphate, we said ZDDPS, are considered to be most successful additives, but due to its toxicity and adverse effect, there is an emergent need to replace the ZDDP. Now, this lubricant researcher trying to replace this ZDP by another material. So nanomaterials are gaining large interest in the lubrication. However, their use in the liquid lubes has been great challenge. This graphene is having very good tribological properties, but the major problem is how to disperse this graphene material in the lube base oil. It's very difficult to disperse the graphene in the lube base oil. So this material is having very good tribological properties because it is easy to sharing, it is having high mechanical strength, we have already seen, excellent heat conductivity, then high surface area near about 2600 meters square per gram, ease of chemical functionalization. Now how these factors affect? Because of the high surface area and ease of chemical functionalization, we can easily functionalize this material, and because of this functionalization, this material can easily disperse in the lube base oil. Then the ease of sharing, high mechanical strength and excellent heat conductivity, they help to reduce the friction and wear. If this material available continuously in between the that interacting surfaces, then that protect the surface from direct contact, and hence if we reduce friction and wear significantly, for that we need good dispersion, and this material should be available continuously during the that relative motion. So by this way we can we can formulate the energy efficient lubricant additives. So in my case, I have functionalized this graphene material by using long alkyl chain, but we need the graphene oxide, that is a very important precursor to prepared functionalized graphene material. So there are various methods to prepare graphene oxide from graphite. One is the Brody method, that is we can use the potassium chlorate, fuming nitric acid. In Stedinmeyer method, he used the potassium chloride and fuming nitric acid and sulfuric acid. Another approach, that is Hoffman, they use potassium KClO3 non-fuming nitric acid and H2SO4. Another approach is Hammer's method. He used the potassium permanganate, sulfuric acid and sodium nitrate. So I have used Hammer's method in order to prepare the graphene oxide by using KMNO4, H2SO4 and NaNO3. Now you can see from graphite to graphite oxide what is happening, that graphite is get oxidized and there is a appearance of these COH groups, epoxy, hydroxyl groups, and when we exfoliate this graphite oxide, then formation of graphene oxide. Now what is the difference between the graphite oxide and graphene oxide? You can see chemically they are the same, but the distance between the layers, you can see the distance between the layer are increasing in the case of graphene oxide. This is because of the exfoliation, and we can exfoliate this material by ultrasonication. So now this graphene oxide I have used for functionalization purpose. So I have inserted the octadecylamine long alkyl chain amines in between these graphene oxide sheets. You can see the interlayer distance increase. You can see this, and because of this long alkyl chain that are easily dispersible in the lube base oil, I have used in in this case, that is 10W40 lube base oil, and then I check the tribological properties. You can see that is the black line, that is for only 10W40 oil, that is the friction. But when I added this functionalized material in the neat oil, what happened? The friction is reduced. You can see as compared to this black line, other colorful lines. In this case, there is a reduction in the friction. And next tribo characterization, you can see in the case if I use 0.02 milligram per ml that functionalized material in the lube base oil, you can see at 0.02 milligram per ml significant reduction in the coefficient of friction. If we in the next graph, if we compare the 10W40 oil and the 0.02 milligram per ml GOODA in presence of this material, you can see that red line, there is significant reduction in the friction. Another graph that shows the wear track depth and wear track depth. You can see in the one example 400 nanometer. Another case 340 nanometer. That 340 nanometer depth is because of this application of this functionalized graphene material. We can reduce the wear track width and depth by using this material. And about mechanism, why the friction or wear is reducing, you can see in this slide. I have shown this graphene blended lube oil. What is happening? Because this graphene sheet is present in between the steel ball and steel disc, or we can say in between the interacting surfaces. So that graphene material will prevent the direct contact between two interacting surfaces, and that's why friction is reduced. That's why wear is reduced. Wear is reduced means to prevent the loss of material because of this relative motion, and this is the mechanism how we can prevent the direct contact, how we can reduce the friction and wear. So this is one example. The next slide is showing this is another material. I have again functionalized this graphene material by using long alkyne chain amine, that is octadecyl amine, particularly at edges. You can see in previous case I have functionalized this material at basal plane, but in this case I have functionalized this material at the edges, and then I check the dispersibility of this material in lube base oil and then the tribological properties. You can see in this case, if we disperse only graphene, it is not dispersible. It is very difficult to disperse. That's why we can't use as a lubricant additive directly. So for dispersion purpose, we have to functionalize this material, and after functionalization, you can see that after 30 days also this dispersion is very stable. So we can use in the tribology, or we can use as a lubricant additive. Now you can see the tribo characterization. This you can see at the 0.02 milligram per ml concentration, we can see how much friction is reduced. The significant reduction in the friction at this concentration. This is the optimized concentration. Another case, you can see at 0.02 milligram per ml how much wear scar diameter reduced. Significant reduction in the wear scar diameter. And these are the images. You can see in the presence of that lubricant additives, the upper images are the absence, in the absence of additives material. You can see wear scar, that circle diameter is higher as compared to the lower images. That lower images is of when I have used the functionalized graphene material as a additive. Then we can see there is no loss of material, and the surface you can see the smoother. So it means surface are smoother, it means friction is less, wear is less. So near about 36% WSD is reduced, and friction also 35% reduced in this case. Another material, that is synthesis of alkyl silane grafted. In previous case I have used octadecylamine. In this case I have used octadecyl trichlorosilane, octadecyl triethoxysilane. I have functionalized this graphene material by using these reagents, and again we have checked the dispersion stability. You can see even 20 days or 15 days, after 15 days this dispersion is very stable. If it is dispersible, then we can use as a lubricant additive. Then we have checked the tribological properties of this material. You can see in the graph at 0.06 concentration or 0.04 concentration, that are the optimized concentration, the significant reduction in the friction and significant reduction in the wear as compared to neat oil or neat lube base oil. So by this way we can reduce friction and wear. In this also you can see, if I functionalize this material with ODTCS or ODTES, you can see that high wear scar diameter is near about 550 in the case of neat oil. But when I use that functionalized material as additive, you can see how there is a reduction in the friction and wear. You can see in this graph. The another work is different. Now I have prepared the graphene material for liquid lubricants. Now this work is not for liquid lubricants. We know that for example the CDs we know in the laptops some frictions occurs in the laptop in the that mechanical system. So sometimes we observe a laptop is heating. Why it is heating? Because some friction is occurring in between the that devices. So how we can reduce the friction in the micro mechanical system? We can deposit the graphene material on silicon substrate. So this is the method how to deposit the the graphene material on silicon substrate. So first of all, I have prepared the hydroxyl terminated silicon substrate. Then this material treated with 3-amino propyl trimethoxysilane, you can see, and in this material amino group is free. So amino group is free. Then this material I have treated with graphene oxide. After treating with this graphene oxide, then we have reduced this material by using VUV radiations, and by this way we have deposited this graphene material on the silicon substrate, which we can use in the micro or nano mechanical system. This is the silicon vapor we use generally in the electronics parts, and I have shown one example or trial result of this material. You can see this is the effect of load on the coefficient of friction. Up to 200 millinewton load, this material can survive for longer time. But you can see that pink line at 200 millinewton load or 300 millinewton load, 400 millinewton load, this material cannot survive. So after 650 laps, the friction increase. You can see after 650 laps, friction increase linearly due to damage of graphene skeleton. If graphene skeleton is there, then there is a reduction in friction. But if we increasing the load, what is happening? This material cannot survive, and hence the friction is increasing. We have checked the durability of this material at particular load. At 100 millinewton load, we got result that up to 37,000 laps this material can survive. This is the best result. Extraordinary wear resistivity we found in the case of this graphene sheet, and this is applicable in the micro or nano electromechanical systems. So this is applicable to the automotive industry or electronic industry. So this is all about the tribological applications. So I think those students who are attending this program, they are lucky because they come to know what is meant by tribology. I know when I enter in the PhD, but they know in their BSc course. So I think they are lucky. So this is all about research result during my PhD, and now you know why this material is known as wonderful material in decade, because it is having extraordinary properties and applications as compared to other graphitic material, and that's why the title of this talk is graphene, that is the wonderful material in a decade. So with this I want to stop my talk. Thank you very much.
Thank you, sir. That was a nice and excellent informations about your work. Now, sir, actually, I have received some questions. So, first question is from Amir Hanif,
Uh,
and the question he is asking, uh, what are the implications in a real world of this study?
yeah. If we add, for example, I have optimized the material in order to reduce the friction or wear. Now this 10W40 oil is already formulated. Yeah, we are using that 10W40 oil, but I think I have already result. So if we add this material, then it will perform nicely as compared to 10W40 oil. So I think if we use this material, definitely there will be reduction in friction as compared to the other oils or 10W40 oil.
Yeah, thank you, sir. Now, sir, we have again next question. Suppose if you doped boron, nitrogen, phosphorus in the graphene oxide layer, can it will help to enhance the tribology study?
Yeah, I think because yeah, some researcher, because in my case I have only functionalized by using long alkyl chain, but we know that as compared to individuals, we know that as compared to individuals compound or molecule, if we dope or if we prepare the composite material, this composite material is having superior properties as compared to individuals. So I think maybe that property will increase.
Yeah. Now I request all the participants in this webinar, if you have any question, please you can directly ask to the sir. Unmute yourself and please go ahead towards your question. I request all the participants. Yeah, one question, sir, I actually received from YouTube,
Okay.
and they are asking what are the development currently are taking in India as compared to the world. Please give us information on the aspects.
Yeah. Yeah. In India also, I have already told ZDP, that is zinc dialkyl dithiophosphates are we are using, but this material is toxic. So we have to replace that material. So know that this Indian oil, HPCL, BPCL, they are also trying to prepare the another materials by which we can replace that ZDDP.
Yeah, thank you, sir. Now again, I request all the participants in the webinar, if you have any query, any doubts regarding the SAR study, please go ahead with your question.
And in India, there is a Tribology Society of India for this work, TSI.
Yes. Or else you can type question in the chat box. So I will share your question with the sir.
Okay.
दिया है ऐसे क्या है नहीं यार
Sir, actually, sir, now I receive again next question from the audience. Uh, what are the different types of material instead of graphene oxide
और लाओ तार बार
for tribology.
ना ना
crocodile है
I think speaking.
आए कहाँ है अभी?
Yeah. Somebody I think speak him. Yes, sir. Wait.
कौन है वो
कल को आएंगे तो फिर परसों को जाओगे, परसों को आएंगे तो फिर नेक्स्ट को जाओगे।
Yes, sir. Please, sir, do one thing. You unmute. Mute all. Mute all first. Yeah. Now you, sir, please on your audio first, sir. Sir, you on your audio first. Yeah.
So what was the question?
Sir, question was, what are the different kind of material in place of graphene oxide we can use to decrease the friction and the wear?
So in my lab, I use the graphene material to reduce friction and wear. Another material we can use as a ionic liquid. Nowadays we are saying that ionic liquid is the green solvent, but that ionic liquid is also useful in the tribology field. And also we can use some metal nanoparticles in order to reduce the friction, or some composite materials. We can use this graphene and ionic liquid composites to reduce this friction, or we can say for tribological purpose.
Yeah, thank you, sir. One question was, can we make graphene sheet in our naked eyes?
Yes.
Yeah.
Single sheet we can.
So question is, can we see graphene sheet by our naked eyes?
Yeah, in literature I have read that because of these optical properties, I think 2.3% that it is optically active, so we can see. I have not seen, but I have read that we can see by naked eyes.
Yeah, thank you, sir. One student from our college, Bhavesh Thakare, is asking, how much hardness is present in a graphene?
Yeah, I have shown the result when I discuss about the properties of graphene. That is 1 terapascal or 1100 gigapascal. That is the tensile or Young modulus, that strength that defines how much hard material is this. And if we compare with the diamond, this material is the strongest as compared to diamond, and that's why we said this is the strongest material ever known.
Yeah, thank you, sir. Sir, next question from Mr. Pramod Kumar, and he's asking how we will effectively functionalize graphene oxide for the better dispersion in aqueous medium.
In aqueous medium, actually, in aqueous medium it is difficult, I think, because for example, water is the polar solvent. So if we put, I think, if we put the polar molecules on the graphene sheet, and this water is also polar, so maybe because of this polar interaction, possibility is there, but it is difficult.
Yes, sir. One question, sir, from again participant. Did you study the effect of different polar solvent on the frictions and the wear
What?
feature? Sir, one person is asking whether you study the effect of different polar solvent on the friction and the wear aspects of the materials.
I have not used the polar solvent, but I have used the synthetic oil, and I have compared with the mineral oils, synthetic and mineral oils, not polar solvents. Because mostly for lubricants we are using the oils. For example, engine oils we are using in the tractors, so motor oils. So I have not used the solvents or organic solvents. I have used that oils, maybe synthetic or mineral oil.
Yeah. So one question again, what is the best technique to functionalize graphene oxide material? And he is giving some choice like HCl, HF, sulfuric acid, KMNO4, and so on. So from your study, please tell us what are the best combination we can use to get good dispersive graphene oxide materials?
Yeah. In my case, I have very easily synthesized, first of all, the graphene oxide. That graphene oxide contains the hydroxyl group, that contains epoxy group, that contains the carboxylic group. So now, of, depending on our target, we can easily functionalize, or we can easily target this hydroxyl group or epoxy group or carboxylic group.
Yeah, thank
So
you,
I
sir.
think no problem. We can easily functionalize
Yeah.
this graphene oxide material, and after that we can reduce this remaining oxygen functional group by using reducing agent, and we get easily the functionalized graphene sheet.
Yeah, thank you, sir. And from all the participants and from all my college staff and on the behalf of all participants, I would like to express my real warm gratitude towards you. You have enlightened us with your knowledge of your PhD work and postdoctoral work, how the tribology studies very important in order to decrease the frictions and the wear. I take privilege to present thanks and for accepting our invitation and giving much valuable information on the carbon-based material. I hope that you have given us sparks to our students. Some of them may will reach a real height in their life. Thank you again, sir, for giving us chance to exploit you at national level. Thank you once again, sir.
Thank you. Thank you.
Now I request my colleague Gode sir to take over technical session 2.
Thank you, sir. So I warmly welcome on the behalf of Rashtrapita Mahatma Gandhi Art and Science College team in a national webinar application of carbon materials. तो हमें इस नेशनल वेबिनार में काफ़ी जगह से लोग ज्वाइन हुए हैं, तो सभी का वेलकम. स्पेशली डॉक्टर दिवेकर सर, साइंटिस्ट, इंडियन इंस्टीट्यूट ऑफ पेट्रोलियम, मोस्टली वेलकम सर. फ्रॉम हैदराबाद, फ्रॉम भोपाल, उत्तराखंड, from Nagpur University members, Gondwana University professors. So all members are welcome in a national webinar. और आज का जो हमारा टॉपिक है एप्लीकेशन ऑफ कार्बन मटेरियल्स, उसके लिए हमारे जो सेकंड टेक्निकल सेशन के गेस्ट है डॉक्टर देवकी नंदन, उनका जो कार्बन मटेरियल पे काम है वो रिकॉग्नाइजेबल काम है और काफ़ी कम उम्र में उन्होंने बहुत बड़ी अचीवमेंट ली हुई है. उनके नाम पे 6 पेटेंट है, 15-20 अच्छे रिसर्च पेपर है, उनको काफ़ी अवार्ड मिल चुके हैं. अवार्ड एक्सचेंज रिसर्च स्टूडेंट बाय ऑस्ट्रेलिया, इंडियन साइंटिस्ट रिसर्च फंड, CSR रिसर्च फेलोशिप उन्हें 2013 में, 2010 में भी मिली थी. और उनका जो वर्क है उनके CV में वैसे दिया हुआ है, मैंने ग्रुप में शेयर किया था. तो जितना उनके CV के बारे में बोला जाए उतना कम है. उनका गूगल टोटल साइटेशन 261 है, उनका H इंडेक्स 7 है. तो मैं डॉक्टर देवकीनंदन सर के रिक्वेस्ट करता हूँ कि वो अपने अपना एक्सपीरियंस हमारे साथ शेयर करें. डॉक्टर देवकीनंदन सर.
Thank you very much. Am I audible?
Yeah.
Yeah. So, good afternoon to all of you. I express my thanks to RMG, Principal RMG College and Professor Nilesh for such a nice introduction. And I am going to talk. Can you make me host now so that I can share my screen?
या आप होस्ट हो सर.
Yes. Are you getting the this screen?
Sir, waiting to open.
Okay. So, I am going to talk on porous carbon composites and their catalytic applications. Before going to start my talk, as here are many students, so after listening this lecture, they will be able to understand how we can make materials and catalysts, and how we prepare the materials, and how we synthesize the material by taking basic and simple ideas, right? So, before going to the porous materials, let us talk about the chemical reactions, how chemical reactions proceed. Are you getting my voice?
Yes, sir.
Yes sir.
Okay. So, you have observed that NH4Cl, if you, is solid, if we put in bottle, it can remain that for many years, right? For if and for sulfuric acid also, if we put in that closed bottle, it will remain for uh, long time, right? But if we put water and sulfuric acid, or if we mix together, then some reactions will happen, right? You may observe in laboratory that we add sulfuric acid in water, not water in sulfuric acid, because this reaction is exothermic reaction. The reaction will proceed like that oxygen give its lone pair to hydrogen, and we will have this type of reaction. Because sulfuric acid is bibasic, so we have this type of reaction, right? So from here you can see that we have the energy profile diagram for exothermic reaction. You can see here that for exothermic reaction, product have less energy than that of reactant. it proceeds through transition state, which is hypothetical, that we only imagine that how reaction will proceed, right? For exothermic reaction, we have this type of energy profile diagram. Now, for endothermic reaction, the example is NH4Cl. If you mix NH4Cl in water, you may have seen in laboratory that if you add NH4Cl in beaker, then there will be cooling effect. How it will happen? That that reactant will take energy from surrounding, so the product will have higher energy than that of reactant. So you can see from here that in exothermic reaction, heat will be transferred from reaction media to surrounding, but for endothermic reaction, heat transferred from surrounding to the reaction medium. So how it will, that reaction will occur? There are 3 or 4 conditions that how reaction will proceed. Number 1, when the charged molecule come close to each other, then they start reaction. Second type of reaction possibility is that when the orbital of reactant will interact. In third type, we have collisions of ions or molecule. And fourth is the, by using catalyst, we can increase or decrease the activation energy or the transition state, where there are 2 types of catalysts. You might be knowing that one is positive catalyst and second is negative catalyst. So here how attraction of reaction take place and reaction will proceed. Here we have that aldehyde and HCl, how they will react. You can see here that hydrogen has del positive charge, carbon has del negative charge, and second molecule, then in aldehyde, carbon has positive charge, oxygen has negative charge. So there will be interaction between positive and negative. Then we will have this type of activated complex, then CN attack on carbon. These are the basic reactions of organic chemistry. We will apply these concept in material synthesis. I will explain it later, that how ammonia react with aldehyde. It will be like this. And how AlCl3 reacts with. Second type of the reactions are when interaction of orbital will take place. Here you can see that alkene react with bromine. How it will react, that you can see from the diagram, that alkene here act as nucleophile and bromine act as electrophile. Why bromine act as electrophile? You have to learn that because alkene has pi cloud, right? And it has highest occupied molecular orbital, while bromine has less electron density in compared to alkene. So its sigma star, like lowest unoccupied molecular orbital, interact with HOMO of alkene, and reaction will proceed through transition state, cyclic transition state. It will opens with the formation of that plus minus dibromobutane. It stereochemistry will depend on the structure of alkene. So third example is that Diels-Alder reaction, where highest occupied molecular orbital of 1,3-butadiene react with lowest unoccupied molecular orbital of the ethylene to give cyclic transition state. This is actually pericyclic reaction. This is thermally allowed reaction. So why I am showing these reactions, that based on these basic idea, if you are going to work in research area in future, so you have to learn basic ideas, and after learning literature, you will find that what chemistry you have to do. So, for example, the next example is that where non-bonding electron act as that attacking, like in HCN, right? Here is the molecular orbital diagram for CN negative. Here you can see that carbon has lone pair and that non-bonding electrons. So it is known as highest occupied molecular orbital. From this highest occupied molecular orbital, electrons will be transferred to the lowest unoccupied orbital of reactant molecules. Third type of reaction is that when collisions of ions or molecule will take place, there are three possibilities. From figure, you can see that when the collision will is strong, that both molecule will achieve the particular activation energy, then we will have the reaction product. But if there is no interaction between collision are not proper, in that case there will be no reaction. What catalyst will do? Actually, my research work in catalysis, so that I prepared many catalyst material which were used for many chemical reactions. So what catalysts do? Catalyst, without catalyst, here you can see that transition state has some level, some activation energy. Activation energy, you might be knowing that the threshold energy which is required to achieve a transition, that maxima, so that we have get the product. So if you have positive catalyst, then catalyst decrease the activation energy. If you have negative catalyst, that increase the activation energy, right? After seeing these basic ideas, now I am going to talk about porous carbon composites and their catalytic application. Why I prepared the composite materials, that you know that sulfuric acid, HCl, H3PO4, they are homogeneous catalysts which are used in many reactions. The idea is that if we introduce SO3H moiety in carbon, so we will have that heterogeneous catalyst which is easily separable. So these will be eco-friendly, non-corrosive, non-toxic, and recyclable, right? So before going to talk about the preparation methods, here is the classification of porous materials. Porous materials can be classified according to their pore size. Here you can see that zeolite related materials have pore size below 2 nanometer, and the clay and LDA have the pore size from 1 to 5 nanometer. In case of mesoporous material, the pore size is between 2 nanometer to 100 nanometer. From 100 nanometer to 3 nanometer, we have macroporous domain. Why I try to prepare porous material? As you know that microporous zeolites has limitation that it cannot be used for bulky molecular transformation. And another drawback of zeolite material is that we have some hydrophilic groups in zeolite, but in porous carbon, if we prepare porous carbon, then we have the more functionalities, and the more, if we have larger porous material, larger pores, then bulky molecules can escape out from these pores, and reaction rate will be increased, right? So the another drawback of zeolite is that because of hydrophilic nature, because most of the reactions we are doing in that where the white water is the side product, or hydrophilic hydrophilic side products. So if we introduce hydrophilic groups in hydrophobic carbon material, we have come back with the this leaching problem, right, which is present in zeolite material. So these are the reported structure of various type of acid functionalized material in literature. So from how I create idea, I want to share that by taking simple idea, I prepared this sulfonated carbon silica materials. In literature, I have seen that many researchers tried a multi-step method for the preparation of sulfonated carbon silica composite material. That two-step method they have used. First, they carbonize the carbon, and in second step, they functionalize this carbon, that carbonized carbon with sulfuric acid. But in my case, what I did, here are the three methods. I can explain first this one. One is post-oxidation method, second is in situ oxidation method, and third is carbonization and sulfonation method. Let us first talk post-oxidation method. In this method, silica source and thiol group containing compound mixed together, and they by condensation reaction they form thiol containing carbon silica composite. On adding oxidant like H2SO4 and other oxidizing agent, we will get sulfonic acid group containing carbon silica composite. In second method, in situ oxidation method, that oxidant, silica source, and thiol group containing compound, by using template or without template and co-condensation, we will have the composite material. Third method is carbonization and sulfonation method. In this method, silica and carbon source first carbonize, and we will have carbon silica composite material. Upon sulfonation, it will give sulfonated carbon silica composite material. Now I am going to present the work which has been done during my PhD study. Simply, I have taken glucose and TOS solution in a beaker, and I added H2SO4 drop by drop. You might be knowing that when we add sulfuric acid in carbon, it will dehydrate, right? In every reaction, like if you add sulfuric acid in alcohol also, you will have get some that dehydrated product. So glucose get dehydrated, and we will have black solid mass. This black solid mass, upon treatment at 300 degree centigrade under nitrogen, we will have sulfonated carbon silica composite. Upon calcination, we will have mesoporous silica. Mesoporous silica have other applications. I am not going in detail. So what are the benefit of sulfonated carbon silica composite prepared by this method, that in two-step method, what happen if you carbonize the sample first carbonize, if you carbonize the sample first, then you will have compact that seeds will form. So after that sulfonation, there are less choice for sulfonation. But if you will do simultaneous carbonization and sulfonation, you will have more choice, because you can understand easily that you have more choice, like in corners, in middle also you will have SO3 H group, OH group of COH group. So you will have that high hydrophilic that group containing catalyst will be formed. So this material has been characterized by various analytical technique. From low angle XRD, you can see that that MS material have more porosity in compared to sulfonated carbon silica composite material. Wide angle XRD pattern shows that the material is ordered amorphous in nature. From porosity, you can see that from nitrogen adsorption, desorption, isotherm, we have type 4 isotherm, which is related to mesoporous material. If we talk about the average pore diameter for SCS material, it is 2.6 nanometer. For MS material, mesoporous silica material, we have 5.3 nanometer. The stability of the material was confirmed by TGA, DTA. You can see that up to 300 degrees centigrade, the material is stable. The high moisture content of this material is due to presence of more hydrophilic groups are present in this material, like OH, SO3H, and COH groups. The presence of various functional groups was confirmed by FTIR analysis. You can see that the peaks related to SO3H containing group COH group containing peaks are visible in SCS material, but in MS material these are disappears, because after calcination the carbon moiety will remove. So it confirms that total removal of carbon from silica. Based on the characterization, we have proposed the mechanism that how material looks like, that in initial hydrolysis, that glucose and TOS get hydrolyzed, and we have small nanoparticles, which upon carbonization and sulfonation give this type of moiety. Upon calcination, we will have this type mesoporous silica material. So the structure of the SCS carbon moiety looks like that. It has OH group, SO3 H group, and COH group. This work has been published in Chemical Communication. Now I am going to talk about the catalytic application. This material was used for alkylation reaction. As you know that phenols are very important candidate for the preparation of polymer industries, and so I chose this reaction, and the basic research on this particular research is that I want to see that effect of porosity, right? How porosity affect. If I use that non-porous carbon, sulfonated carbon material, we have less selectivity for 2,4 ditertiary butyl alcohol. But in case of porous material, we have more selectivity for 2,4-nitrosylbutanol. Here is the recycling experiment. In here you can see that after third run, we have not marginal difference in the conversion. So we can say that material is stable. This work was extended for optimization of the carbon silica composite material. Two methods I was adopted. First is that before sulfonation, before before carbonization at 300 degrees centigrade, the black solid mass was treated under 170 degrees centigrade inside autoclave. Second is normal, which is operated in the previously synthesized chemical communication article. So the purpose of this study was that how, because you know that glucose is the source of carbon. So I have varied with different concentration of glucose to see the effect on the acidity of the final material. Various materials had been synthesized, and we conclude that that hydrothermally synthesized sample has more porosity, more porous, because you know that if you do the reaction in open that beaker, there is less tendency, less interaction between the reactant. But inside autoclave, there will be more possibility of interaction. So in here you can see that from the mechanism that in case of HSCS material, we have less localized carbon, right? So we can say that more ordered materials we can get from this hydrothermal treatment, right? This material, this work has been proposed in that published in microporous mesoporous material. You can go through this article. If you want to learn, I can provide this. You can contact me directly. So for this reaction, these materials applied, the synthesized material were applied for saltpeter production. Saltpeter is a very important chemical the synthesized material for saltpeter preparation. Here you can see that HSCS version up to 82 degrees centigrade. Oh, sorry, 82%. Now, the second topic of my research is that I have find that before when I used this carbon silica composite material, I have seen that there is the problem of separation, because this carbon has nanoparticle, nano composite. So I have tried to prepare magnetically separable carbon composites. How I prepared this material, I can explain that by taking simple idea, like first I have taken levulinic acid and fluoroglucinol. The basic chemistry for this preparation is that levulinic acid has COH group, which can act as capping agent for metal absorption, light metal, that metal salt will interact with COH, which we have seen that how that plus and minus interact, right? So COH group interacts with metal, and CO group. CO group will interact with that fluoroglycinol. Actually, fluoroglycinol was the carbon, that carbon source, right? These precursors were mixed together in beaker. Upon hydrothermal crystallization at 170 degrees centigrade, we have get solid that polymer, which upon treatment at 500 degrees centigrade under nitrogen for 4 hours, we have magnetically separable carbon supported metal nanoparticles. Here you can see that how this material can be separable by that magnet. You can see the photograph showing that magnetic separation of NiFe2O4 nanoparticles at carbon. These are the same images of the material, how the nanoparticles looks like. These are spherical in nature, but in case of NiFe2O4, there is more agglomeration, but in case of COFe2O4, there is less agglomeration. These are the time images where you can see the small black spots which show the presence of metal. These are the XRD pattern. As you know that you are learning XRD, so in future if you are going to do research, so that from XRD we will get the information upon the crystalline pattern of the that nanoparticles of zeolite. Here you can see that the presence of XRD pattern shows that the spinel structure was observed for all the cases. But in case of that ZNO, ZnFe2O4, there is some impurity of ZNO was also visible. The presence of spinal structure was crossed, confirmed by TAM images, where we can see that actually de-spacing we can learn from XRD spectra, right? MSc student can calculate that how they get Miller from Miller indices. You will get the de-spacing and what is the plane, right? So this was confirmed by TAM images that the de-spacing of 0.25 nanometer was visible in all cases. So we can say that spinal structure of the MFE2O4 at carbon was confirmed. Based on the characterization, here is the proposed mechanism that how we will have the polymer interacted metals looks like. That CO group react with this one, this hydrogen by simple alkylation, right? That COH group interact with M+2 or +3. We will have polymer interacted metal. Upon carbonization, we will have this type of structure. This work was published in Dalton transaction. The prepared material was used for hydrogenation reaction. Most of you know that the nickel, zinc, and cobalt act as the catalyst for hydrogenation reaction. So I tried this material for that hydrogenation of ethyl benzene. We will have the 100% conversion in case of NiFe2O4 at carbon. How we see that the spatial combination of NiFe2O4 at carbon give 100% conversion. Here I have tried normal ions which were not give that conversion, so that I can say that this material have specific active sites for that hydrogenation reaction. So these are the other reactions. I have tried that whether this catalyst is used for other alkenes, like for cyclohexene, it gave 70% conversion. For cyclohexanone, it gave 0%. So this material has special selectivity for that alkylated side chain, like for ethyl base. These are the recycling experiment. This material is stable up to 4 sides. Now, the next chapter, or we can say that next topic, is that cobalt entrenched anisodope tridoped carbons as efficient multifunctional catalyst for base-free selective oxidative acidification of alcohols. So, how I prepared the material, the basic idea about the preparation is that I have seen in literature, and during my when I was in project assistant in Bhavnagar, I observed that carrageenan has gelling properties, right? And second is that that cobalt can interact with urea. Second idea. So that I tried to trap the cobalt interacted urea inside the gel. The idea, basic idea was that because you know that if we do not coat the nanoparticles, so you will have leaching problems, right? And because of addition of that nitrogen and sulfur and oxygen, both right all that heteroatom containing that heteroatoms have the electron lone pair, which will increase the electron density in carbon. So the basic idea is that I want to prepare that cobalt injected that entrenched anisodoped carbon materials. So these CO that urea that CO interacted urea was trapped inside the carrageenan gel. Upon carbonization, we will have cobalt at NOSC. This material was published in Green Chemistry. These are the characterization. Powder XRD pattern shows that the metal has metallic cobalt, cobalt sulfide, right? And some small amount of cobalt oxide. The presence of various functionalities like the D spacing for cobalt sulfide comes around 0.29 nanometer. For metallic cobalt, it is 0.29 nanometer. For that graphitic carbon, we have the D spacing of 3 nanometer, right? 3.2 nanometer. So the TAM images show the presence of we can say that cobalt is coated with the anisodope carbon moiety. Here you can see the nice picture for HRTM, which comes from that how the cobalt coated. In first image, you can see that normal carbon have the blue color. You cannot see that cobalt moiety. Second one is nitrogen. So from here, you can see that cobalt in shown in red color coated with nitrogen, carbon, sulfur, and oxygen. Presence of all the group like pyridinic nitrogens, pyrolytic nitrogen was further confirmed by XPS analysis. Based on the properties, I have choose this one is esterification reaction. So in literature, I have find that cobalt was used um, uh, the esterification reaction, but they use base like NaOH and that cobalt-based material. But here, I did not use any base. The nitrogen, oxygen, sulfur, they act as the activating agent for this reaction. So you know that pyridinic nitrogen can act as base. So base-free oxidative esterification was achieved by using this material. Here you can see that we have achieved 99% conversion for CO at NOSC when I use 50 mg catalyst, right? Uh, these are the reactant. Reaction was various substrate scopes has been done. These are the recycling experiment that we have seen that the material is stable. Here we proposed a mechanism based on the characterization. We did ESR, EPR study of reaction media. So we have trapped CH2OH free radical and H free radical. You know that how ESR, that free radical can be trapped by POBN. So that we have see that the presence of hydrogen free radical and CH2OH free radical based on this ESR that trapping, we propose the mechanism that how mechanism proceed. Here you can see that cobalt, which can be seen in red color, absorbed, transfer its electron to oxygen, right? This reaction was done under oxygen. It will give superoxide. This superoxide attack on methanol give this CH2 OH free radical and OOH free radical, because we have metal, cobalt metal in that catalyst. It can easily decompose H2O2 in two OH free radicals. This free radical attack on aldehyde, alcohol, give aldehyde, right? Actually, this because we have excess amount of methanol. So at 60 degrees centigrade, that in presence of free radical, we will have first we have acetal, which upon reaction with this one free radical, we will have ester, right? These are the topic which has been covered during my doctoral studies. So I want to share that by taking simple ideas, how you can get the publication and how you can get the desired catalyst by taking simple. I did not take in much complex chemistry. By applying simple chemistry, I achieved these materials. The first material was patented. We have US patent for that. So because that material is very stable for where the reaction having that polar environment, right? Thank you very much.
Thank you, sir, for nice presentation and sharing your experience. If anyone have question, can type in chat box और by unmute his mic you can ask question. तब तक सर मेरे तरफ से एक क्वेश्चन है कि ये एटोक्लेव और नाइट्रोजन एटमॉस्फेयर वाला अगर स्टेप को हम कुछ अल्टरनेटिव दे सकते हैं क्या, जो जनरली बीएससी लैब में अवेलेबल नहीं रहता?
बीएससी लेवल यू कैन डू इट, आप कर सकते हैं, लेकिन क्या है कि स्टेबिलिटी में फर्क पड़ेगा। अगर आप नॉर्मली बनाएंगे तो स्टेबल नहीं रहेगा, बिकॉज कार्बोनाइजेशन का पर्पज क्या है कि मॉलिक्यूल को स्टेबल कर सके, राइट? अगर नॉर्मली आप लैब में बनाओगे तो वो नैनो पार्टिकल्स, वो भी आई थिंक पब्लिकेशंस हैं उसमें, उसके लिए आप दूसरा मेथड जो है बाय यूजिंग एसएच ग्रुप कंटेनिंग दैट सिलेन compound, right? After oxidizing with H2O2 and other oxidizing agent, you will get SO3H. But that have you will not get a porous material.
अच्छा अच्छा,
right? porous material में क्या होगा कि आप छोटे छोटे मॉलिक्यूल्स, बल्कि मोलिकुलर ट्रांसफॉर्मेशन कर नहीं पाएंगे। लाइक जैसे मैंने फिनॉल का एल्काइलेशन किया तो टर्सिड ब्यूटाइल अल्कोहल लिया, राइट? तो वो अच्छा एक्टिविटी देता है।
हाँ, अच्छा अच्छा अच्छा। सो क्वेश्चन फ्रॉम ऑडियंस। सो
nice talk, sir. Sir, I'm having one question regarding conversion of styrene to ethyl benzene. You have used spinel-based catalyst support on carbon. Whether you have compared nickel particles supported on the carbon material?
I did not use that supported on carbon. Normally I have used only that वो जो आयंस थे विदाउट कार्बन, जो सपोर्टेड कार्बन पे नहीं यूज।
Because sir, now we have used the spinel containing nickel iron.
Yes,
So
yes.
whether it can be comparable with the nickel particles only?
Actually, in literature you can see that nickel act as a hydrogenating agent. So nickel on carbon can act, but I have seen in literature that there is less conversion for this nickel on carbon. Platinum or on carbon can give more conversion. But if you take simply nickel, so I think you will have like yes, याद आया, उसके लिए आपको हाई टेम्परेचर की जरूरत होती है। इसमें लेस टेम्परेचर 80 डिग्री पे रिएक्शन हुआ है।
Yeah, thank you, sir.
सो टेक्निकल सेक्शन सेकंड होने की वजह से काफ़ी लोगों का नेट पैक भी ख़त्म हुआ होगा, तो पार्टिसिपेंट भी थोड़ा से रिड्यूस हो गए, लेकिन सेशन बहुत अच्छा रहा। प्रेजेंटेशन काफ़ी अच्छा बना, बहुत आपने उस पर मेहनत ली है। और लड़कों के लिए भी, बीएससी और एमएससी के लड़कों के लिए मैं स्पेशल बताना चाहता हूँ कि डॉक्टर देवकीनंदन सर का यूट्यूब चैनल है, उसमें उन्होंने बहुत काफ़ी अच्छी तरीके से सब्जेक्ट को एक्सप्लेन किया है, काफ़ी मेहनत ली है। उनके प्रेजेंटेशन, एनिमेशन बहुत अच्छे हैं। तो मैं लड़कों के लिए स्पेशल सजेस्ट करूंगा कि आप उनके यूट्यूब चैनल से काफ़ी टॉपिक पढ़ सकते हो, उनके साथ डिस्कस कर सकते हो। और वो अभी फ़िलहाल प्रोफेसर ही है डिग्री कॉलेज के, तो आप उनसे भी कुछ सीख सकते हो। ये एक अच्छा चांस है। वो हमारे कॉलेज से अभी
यू कैन आप उसको कोई भी बच्चों को मेरा नंबर शेयर, जितने भी सुन रहे हैं उनको नंबर शेयर कर सकते हैं, कोई भी टॉपिक हो उससे रिलेटेड क्वेश्चन पूछ सकते हैं।
थैंक यू सर। तो हमारे लिए भी एक अच्छी अपॉर्चुनिटी आ गई है। तो अभी ये टेक्निकल सेशन सेकंड यहाँ पे फिनिश हुआ, ऐसा मैं डिक्लेयर करता हूँ। और डॉक्टर देवकीनंदन सर का फिर से मैं काफ़ी डॉक्टर देवकीनंदन सर के काफ़ी थैंकफुल है हम सभी। और नेक्स्ट वोट ऑफ थैंक्स सेशन के लिए मैं खोबरागढ़े सर की रिक्वेस्ट करता हूँ।
Good afternoon, one and all. I, Prem Kumar Kobragade, on behalf of Rashtrapita Mahatma Gandhi Arts and Science College, Nagpur. It gives me for this one-day webinar on the topic applications of carbon materials to all dignitaries. I would like to thank our first guest speaker, Dr. Harshal Mungse sir, Department of Chemistry, Adarsh Science College, Dhamangaon, Sant Gadge Baba, Amravati University, India. I would like to thank our second guest speaker, Dr. Devkinandan sir, Department of Chemistry, Government Degree College, Tanakpur, Humayun University, Uttarakhand, India. Also, I would like to thank our beloved principal, Dr. A.N. Korpenwar sir. Also, I would like to thank all staff members and all participants for making this webinar as a grand success. Once again, I thanks one and all present here. Thank you.
तो ये नेशनल वेबिनार ऑन एप्लीकेशन ऑफ मटेरियल साइंस के दोनों भी
आपको भी
टेक्निकल
बहुत
सेशन
बहुत कॉन्ग्रेचुलेशन।
और जिनको सर्टिफिकेट की ज़रूरत है उन्होंने फीडबैक फॉर्म ज़रूर फिलअप करना। सारे पार्टिसिपेंट ने फीडबैक फॉर्म ज़रूर फिलअप करना। फीडबैक फॉर्म का स्पेशल लिंक व्हाट्सएप ग्रुप पे डाला है, तो कल तक वो सर्टिफिकेट आपके आ जाएंगे। और जिससे भी किसी को भी अगर सर्टिफिकेट में अगर कुछ प्रॉब्लम हो तो पर्सनली भी आप कांटेक्ट कर सकते हो। हमारा कांटेक्ट नंबर उस ब्राउचर में दिया हुआ है। वंस अगेन थैंक यू ऑल। और ये नेशनल सेमिनार यहाँ पे फिनिश हुआ ऐसा मैं डिक्लेयर करता हूँ। थैंक यू वेरी मच।